Hi friends, good morning, welcome to GATE Academy. Good morning Narendra, good morning Abhishek, good morning Bhaskar Tyagarajan. You know, yesterday the person Bhaskar that you are seeing right here, he, uh, he messaged me. I thought like normally he is also a student of 21 years of age, but no, he is of age of 53 years. He is of 53 years age, and after marrying and having children, now he is preparing for GATE. Like why he has given GATE in 1998, 99, 2000 it seems, but after 20 years he is still preparing for GATE, and the idea is like he wants to clear the GATE and do whatever it is. There are people who are passionate about education even at their later stages. Reading up to preparing for anything up to 25 years itself is a huge task. After 25, what we feel is we can't study this, we can't study that, we can't do, we are exhausted with the education and all those things. But there are people like him who is doing, who is having interest even at the later stages of life. Even after having the family tensions, pressures and all those things, he is coping up with that. At the same time, he wants to study. That too, it's not like normal he is going to college and all those things. He wants to clear GATE, competitive exams. So what I can say is, age is just a barrier. I mean, age is just your mindset. If you want to do wonders, you can do wonders at any point of your life. That was a bigger inspiration. This is not the first person whom I have seen that preparing. There are people who after retirement are also preparing for GATE because they have not cleared GATE in the earlier stages. Now they are preparing for GATE. They have cleared the, they are clearing the GATE, getting MTech seats, PhD seats, doing PhD. So it's all like your mindset, your confidence, and whatever you want to achieve in the life. You're getting it? So nothing is a barrier. Nothing is a barrier. If you want to get something, you'll definitely get it. Your mindset should not be like, okay, my age is gone, or I have this problem, I have that problem. A person at the age of 53 who is having a family and a kid, do you think that he'll be having more problems than you? At the age of 20 and 21, what is your biggest problem? You are not taking care of your family financially. You will not be having any family pressures, tensions. Your just idea is to eat, sleep, study, and get a better job. Right? Your main focus should be like this. Your focus should not be like, even though if you are worried about your family financial status, but you can't do anything. Only if you get job, then your life would be better, right? So the thing is, at this age, compared to that the age of 53 years person, 20, 21 to 23 age, it's like you don't have much of work. Your only work is to study. Just don't worry about anything. Just study, relax, study, and then reach to the greater heights. Achieve whatever you want to achieve. So we can take inspiration from people like this. So suddenly when he messaged me yesterday saying that, sir, I am 53 years of age, I was like, sir, at this age why you are studying? And he was like, I want to clear GATE. So it's a nice interaction actually. It's like an inspiration to me also. That means if you want to study, like in future also, if I want to pursue any course, it's like age is not a barrier. Age is never a barrier. Like MS Dhoni says, age is never a barrier. It's your mindset, how exactly you perform and what is your enthusiasm over there. Fine. Actually, it's a nice inspiration from that guy. Yeah. So what about the other guys? Mahima, good morning, and Khan, good morning. What is the meaning of GATE examination? If you ask me, yeah, once upon a time the GATE examination is for MTech. After that, PSU started recruiting through GATE because GATE is a good examination. And now once again, some PSUs like what? But even now all the PSUs haven't left. There are certain PSUs that is recruiting through GATE. And you know what, sir, if PSUs are conducting their own examinations, what is the use of GATE? Whatever you are preparing here, same questions will be asked in the PSUs. It's not like they'll go out of the concept. They'll ask questions from the same concept. So whatever you are learning here, that will be useful over there. That is one thing. And other thing is, if PSUs stop recruiting through GATE, then there is a possibility that MTech might shine. Why, sir? Because the toppers, whoever gets the better ranks, generally they go to PSUs. Now what they'll do, they'll start doing MTech. And what happens if they do MTech? That means the higher education gets the better value. It's not like all the IITs and all those things, they got brand name because of the better students. So if the best students go and pursue MTech over there, there will be huge amount of researchers. If there is high amount of researchers, then automatically the value changes. Value for the MTech in India changes. Like value for MS in US is higher. If you ask me, they see that person who has got MS degree or PhD. They'll be given much more value over there. The same thing happens here also. So the MTech gets the better value if people from the people who are really working hard and smart enough does the MTech. MTech gets the better value. At the same time, the recruitment from the MTech will increase. That means you will be given best opportunities over there. The private companies which are paying 4 to 5 lakhs right now, they might pay 10 to 12 lakhs tomorrow, or even more than that, or equivalent to that software guys, you will be paid. Like there will be more amount of researchers. So if one thing is going, automatically other thing will come. Your work is to stick to your basics and work hard on it. Like if you prepare hard on it and if you are knowledgeable, then automatically one or other opportunity comes your way. Take that opportunity, utilize that for the better life. So keep a positive mode here. Always negative mode, like PSUs is gone. If PSU is gone, it's okay. You go do your MTech. That MTech will fetch you a better job. Obviously, may not government job, but better job. It's not like government is the biggest thing here. In our I'll tell you what. In our forefathers' day, what was the government job? Government job, it's like in our grandfather's period or in our father's period or before evolution of software engineers, this government job is considered as best thing. Why? Because the only job is government job. If not, you have to do agriculture, or based on the agriculture you have to do the businesses. But once the private job came into the picture, then what happens? The value for the government job went down like anything. Like in government job, you will be getting 20,000, 25,000, or if you are corrupted, then only you will be getting more amount of money. Whereas, and there is huge amount of risk in the corruption. Whereas in private job, it's like more of your talent. Softwares, like you go, you showcase your talent, and you get the better jobs. And they earned more, they went to US, they went to the world, they traveled the world. Even now, because of the private industry people are earning more compared to that of government sector. And in last 5 to 10 years, once again government job came into the picture. Why? Because of increasing the scale, PRC came into the picture. So government job people like, okay, government job we are getting 60 to 70k per month, so 80k per month, and working hours is 8 hours, so PSU is the better job. That's what we are thinking. And in future, there is a possibility that if the pay scale in the private sector also increases, that means if starting pay itself is 60 to 70k, then automatically government job loses its favor, loses its color, automatically private job goes. But whatever it is, if you want government job or private job, the only thing that matters is your talent, your knowledge, and all the other stuff. Your knowledge is really important. That means if you know all this knowledge of whether it is technical knowledge or interpersonal skills or managerial skills, automatically you will be landed in a better job, where if you work hard, you will reach the heights. So instead of giving reasons, try to find the solutions. There you can give many reasons, and the reasons will be used for the for politics. If you say we don't have jobs for this, then the people in the opposition, they say that once we come into the power, we'll give it, and people in the people in the government, they'll use politics out of it. So it will be made politics out of it. You can put a reason, at the same time work hard to get the better life. because you can't live with the reasons, and reasons will not provide you the food. You have to work hard. And once if government changes, if they really give some PRCs or some new jobs, then go for it. There's nothing wrong in that. Okay. So that's a nice discussion, yeah. Age is just a number according to MS Dhoni. To compete among one's competence to sustain passion for higher education. So yeah, that is the guy Bhaskar for you. So these are some inspirational, like inspiration doesn't come from outside, inspiration comes from within. So this is the thing. And now coming to the class, I was discussing, I have completed railways and highways, right? Now we will be discussing airport. Airport engineering. So if we stopped at highways, we would have never got railways. If we stopped at railways, we would have never got airport. Supersonic jets, fighter flights, all those things. We keep on rockets and all those things. We keep on improving ourselves. Recently, Jeff Bezos, Amazon founder, has prepared his own rocket, and he is going to, I think he is going to Mars, right? So yeah, he is going with his Mars or Moon, Mars, I think. 3 people are going on their own. So tomorrow you can also earn that much amount of money and go to the space, all those things. What exactly is Amazon guy is doing? He is indirectly, like he's indirectly doing brokerage. Like he gets the goods, he transfers the goods from one place to the other place. You sitting at your home can order, and whatever the broker commission he gets, he is getting that commission only. With that commission, he has become a billionaire. So you can see even the small amount of money, 1 rupee, 2 rupees of commission makes you a billionaire. All these things are in your head, mind. What he has done, he has just increased the connectivity between the people, and then he earned money. So it's not like, sir, he has to be software engineer, he has to be that engineer, civil engineer, all those things. No, it's your mindset that makes you earn money. Your smartness helps you get money. And like there are 2 things in the society, money, name and fame, right? Like if you are more worried about name and fame in the society, then you should be either politician or an actor, something like this. If you want money, then you should be more into the business thing. And businessman plus politician, then you might get your name, fame, name, all those things. And if you want a good name, like in people, all the people should praise you, then what you have to do, you have to give freebies. Like if you freely give all the things to the people, then okay, they feel like, okay, he is great, he is great, he is great. So everything is interlinked. Fine. Anyway, so we came to the airport. So till now first we traveled in the buses, that is highway. Next we traveled in the trains. Now we are going in flight. So get ready, guys, flight is about to take off. Here we are not going to design flights, we are not going to design anything regarding the flights, wings and aircraft engines and all those things. Our main idea is to design what? Runways and taxiways. Our main idea is to design exactly the roads that is present at the airport. We are not worried about how plane is going to fly. That is mechanical engineer's headache. Our main problem is to design the road, to design the runways, to design the highways, so to design the runways or to design the taxiways, so that it can take the aircraft, so that aircraft can easily move on those roads. Our main idea is this. We don't have any other problem with engines and all those things. Fine. Even in highways, what we have designed, we have not designed buses, we have designed roads. In railways, we have designed rails. We have not designed this trains. Trains is mechanical engineer headache, and then buses is a mechanical engineer headache, and aircraft is mechanical engineer's headache. It's only roads. The way is provided by the civil engineers. Fine. So, we actually in practical both mechanical engineers and civil engineers will be correlated and they will be doing the work, but you know the CSE guys and CSE guys earns more amount of money because they are developing softwares. All those things, the buildings, everything. Electrical guys, all we are all considered as core guys, electrical, civil, mechanical, and we don't get much salaries, but CSE guys will get much salaries because they create this platform called softwares, like your phones, all those things. They created, the technology is imposed on us. That is like what is the basic needs? Food, shelter, dress. These are the basic needs. Now technology became our another basic need that was imposed on us by these all software guys, and now software guys are considered better compared. Initially the engineers means either civil engineer, mechanical engineer or electrical engineer. Once introduction of the computers, that is softwares, then computer science engineers came into the picture. Now software engineer means software engineer. They don't even you know, in India civil engineers or mechanical engineers are not given that much worth, whereas in US and UK they are giving. Yeah. So airport engineering, generally airport is controlled by ICAO, International Civil Aviation Organization, International Civil Aviation Organization. This is from international point of view, whereas from India point of view, it will be organized by Airport Authority of India. Airport Authority of India. Airport Authority of India. Fine. So, and airports is classified into different types. First, based on runway length, based on runway length, based on runway length, based on runway length, runway length. Types of airports, if you ask me, types of airports, types of airports based on runway length, ICAO specifies airport from A to E categories, A to E category, or divides airports from A to E category. A represents airport with longer runway length, airport with longer runway length, with longer runway length, with longer runway length, and E represents airport with shorter runway length, airport with shorter runway length, airport with shorter runway length. This is two different things: airport with longer runway length, airport with shorter runway length. Fine. This is based on runway length category, based on runway length, types of airports. Then based on ESWL, equivalent single wheel load. Based on ESWL, airports are classified from, airports are classified into, airports are classified, airports are classified from number 1 to 7. Airports are classified from number 1 to 7. 1 represents higher ESWL, whereas 7 represents lower ESWL, equivalent single wheel load. There will be different wheel loads. So higher ESWL and lower ESWL. Airports are classified into different numbers 1 to 7. Here airports are classified from A to E, where A is the airport having higher runway length, longer runway length, and E is the airport which is having shorter runway length. ESWL, which I have already discussed, equivalent single wheel load. Equivalent single wheel load. Fine. So, any doubts in this? You can ask me. Good morning, Kushbuja. Any doubts? Any doubts? No doubts? Fine. This is types of airports, and coming to then you might be seeing different things, but from exam point of view only I am discussing. First one is runway. Runway. The name itself says runway means it is the way that is provided for the aircraft to run. That means indirectly it is the road that is constructed where takeoff and landing takes place. It is the path that is constructed on which takeoff or landing takes place, right? That is runway. It is the path. It is the path that is constructed. That is constructed for takeoff and landing. For takeoff and landing. This is generally constructed for takeoff and landing. How exactly it is constructed? I mean, the very basic principle for constructing of the runway is runway should be in the direction. Runway should be in the direction. Runway is constructed or oriented in the direction of prevailing wind. In the direction of prevailing wind. Runway is constructed or oriented in the direction of the prevailing wind. Fine. So, that means in the direction of the wind, runway is generally oriented or constructed. Why, sir? So that the headwind component, what exactly headwind component is? Whenever a flight is taking off, let us say, whenever let us say a flight is taking off, something like this, your wind component should be something like, if it is like this, this is called as headwind component. This is called as headwind component. Okay. So, your takeoff, your wind component, headwind component should be opposite to the direction of takeoff. If it is opposite to the direction of takeoff, then what happens is, if let us say it is taking off like this, if wind is like this, what happens? Wind helps to move upwards. Wind helps to move upwards. So, that means automatically the speed will increase. That means wind comes and wind pushes. It provides uplift to the aircraft while taking off. It provides uplift to the aircraft while taking off. So, generally let us say for takeoff, if it has to travel this much amount of distance, if there is no wind, for getting certain speed, it will travel, it goes up to this and then it will flies, let us say. That is if there is no wind. If there is less amount, if there is huge amount of winds, there is huge amount of wind components like this, then what happens when wind comes, if it goes like this, it can easily take off because wind pushes to move it to the topper direction with and gets higher speeds, right. So during takeoff it helps something like this, that means uplift will be more, uplift will be more, uplift will be more. This is headwind component takeoff, this is headwind, headwind. This is during takeoff. At the same time during landing what happens? During landing, during landing, that means let us say if flight is landing something like this, let us say winds are coming like this. During landing what happens? If there is no wind, it lands and then it slowly goes on the runway like this. If it is landing and wind is coming like this, then what happens is wind pushes it downwards, wind pushes it downwards so that it can land easily, right. That means the runway length here will also be reduced. So the runway should be oriented in the direction of the wind, but take off and while during, so that while taking off or landing, headwind component is opposite to the direction of the flight, so that we can require shorter runway lengths. Fine, this is during landing, this is during landing, this is during landing. I am talking about headwind component, not crosswind component. This is called as headwind component that helps to uplift the aircraft while takeoff and that helps to decrease the speed of the flight while landing. Fine. So generally, you know, this the pilot whenever he is the experience or you know the efficiency of pilot involves whether he is able to take off properly or at the same time he is able to land properly. Generally, you know, takeoff takes some more amount of time. Instead of going for 10 meters distance or 50 meters distance or let us say 200 meters distance, he'll travel like he'll keep on rounding. Why? Because he doesn't get that proper speed. So he'll wait for the wind. Once wind comes, he'll take off. If without wind he takes off, then you will feel some amount of jerk over there. At the same time, if without wind he lands, then it is not called as proper landing. So according to the wind orientation, he has to land. That is smooth landing, smooth takeoff will be there. Fine. So any doubts in this? Any doubts in this? Only 4 people are watching. Thank you very much here. And there were 25 likes and now it went to 23 likes. This is also even better. Any doubts? No doubts? Clear? So you can take a note over here. Take a note over here. Headwind components, headwind component, headwind component provides greater uplift force, greater uplift force on wings of the aircraft, greater uplift force on wings, greater uplift force on the wings of the aircraft, greater uplift force on the wings of the aircraft. Headwind component provides greater uplift force on the wings of the aircraft so that aircraft gets higher speed, or so that aircraft goes above ground level, in shorter length of in shorter length of runways, goes above in shorter length of runways. That is headwind component. Next, while during takeoff, uplift force, sorry, write it down here, during takeoff, yeah. Headwind component provides greater uplift force on the wings of aircraft during takeoff, so that aircraft goes above the ground level in shorter length of runways. And during landing of aircraft, headwind component during landing of aircraft, headwind component opposes the helps in reduction of speed of aircraft, thus aircraft comes onto the ground level in shorter lengths of runways. We try to reduce the lengths of runways, because if length of runway is more, automatically the cost of airport increases. That's why. Fine. So this is the idea of headwind component. Next one is crosswind component. That means throughout the year, winds will not be flowing like this. Winds can be flowing like this also, right? Throughout the year, there will not be central winds. Winds will be flowing like this also, with some amount of speed v. Fine, with some amount of speed v. So when it is flowing like that, if this is the wind, there will be two components for it. If this is theta, this would be v cos theta, and this is v sin theta. V cos theta, v sin theta. This indirectly is called as headwind component. Indirectly works as headwind component. This would be called crosswind component. V sin theta is called as crosswind component. So what exactly happens is, when crosswind moves like this, when there is wind like this, what happens? When there is takeoff, it helps so that it can easily move like this. But while landing, if there is crosswind component, it can't land properly. There will be some turbulence, disturbance. So whenever, if you have traveled in the flight, you might felt some turbulence. While landing, there might be some amount of turbulence, because there will be huge amount of crosswind component. So while designing, you should consider crosswind component also, because it actually causes disturbances while landing, or it causes turbulence while landing and takeoff. Fine. So crosswind component v sin theta helps while taking off, but causes turbulence while landing. Fine. Any doubts in this? You can ask me. Only 5 people are watching. Please do like, share, subscribe with as many people as possible. Why are even today also only 5 people are watching? Any doubts, guys? Please comment. Who are those 5 people? Me, Narendra, Kushbu, 3 people. Me, Narendra, Kushbu. Who are those other 3 people? Who are the other 3 people? 3, 4 guys. Please do comment, guys. If you don't comment, how could I know that who are watching, who are not watching? You don't want to comment? You don't like talking with me? It's okay. Fine. So this is headwind component and crosswind components. Once headwind component, crosswind component completes, next one is how exactly this wind component and all those things. For that, generally we draw a diagram which is called as windrose diagram. Windrose diagram. Windrose diagram. It is graphical representation of. It is graphical representation of. It is graphical representation of. Graphical representation. It is graphical representation of direction, duration, and intensity of wind, at any given location, at any given location. Where it is helpful? It is helpful in designing of runways. It is helpful in designing of runways. There are different types of windrose diagrams. The very basic type, if you want me to discuss, that would be something like this. Generally this is west, this is north, this is south, this is east, right? So in a given direction, and these circles represents the speed, like generally speed is given in nautical miles. So if the circle is like I'll say this is 2 to 4 knots, and this would be some 4 to 6 knots. This would be some 6 to 10 knots. Knots means nautical miles per hour. Winds are generally given. This windrose diagram is developed before the compass only, to see the direction of the wind. Fine. And this is some 11 to 16 knots, and from 16 to 19 knots. Fine. So, and generally if you see if there is a curve something like this, or there will be this shaded portion. This will be the shaded portion in this direction, and shaded portion in this direction, it can be like this. In the south, it can, in the east, it can be the shaded portion, and in the north, this can be the shaded portion. Fine. So, what exactly this represents is, what exactly this represents? That means out of out of whole wind components, there will be like majority of westerly winds is there. Whenever you see this, if there is huge amount of the percentage will be given to you. Let us say there is some 28% of westerly winds. Out of 100% of winds, there is 28% or maximum percent of westerly winds. If in an year I am talking, in an year, this is the maximum percentage of westerly winds. That means 28 or 30% of westerly winds is there. Then what you will do is, you will orient your runway in this direction. In that westerly winds also, in that 30%, or let us say in 30% of westerly winds, winds with 2 to 4 knots speed will be this much. Winds with 4 to 6 knots will be this much percentage. Let us say it can be some 5%, 6%, 7%, 8%, 10%. Out of that 30% of winds with, like let us say, suppose I will not, this is not correct way, but I am just saying, out of 100 times, 30 times in an year, there is only westerly winds. 30 times in an year, there is only westerly winds. In that 30 times, winds with 11 to 16 to 19 knots is, let us say, only for some 10 times, and winds with 6 to 10, it can be only for some 40 times. Out of that 30 times of westerly winds, this is further categorized into this. Based on that, you will design your runway. This is a windrows diagram. This is one of the windrows diagram. Windrows diagram. So according to the place where there is maximum wind, or wind at which speed you require, based on the speed and the direction of the wind, you will design your runway. So generally, if winds are more in the western direction, and whatever all the criteria are satisfied, then I will provide runway like this. I will provide runway like this. Width of the runway also, if I am restricting it from here to here, means I require only 4 to 6 knots speed. If I am providing it like this, then speed of the winds over would be 16 to 19 knots. That is the meaning of it. So once again I am saying, windrows diagram is the graphical representation of direction, duration and intensity of the wind. Fine. So direction would be like this. Direction is westerly winds, northern winds, easterly winds and southern winds. And duration if the shaded region shows for how much duration. So if it is more, means like if out of the whole graph the shaded region is more over here, means that means more winds will be moving in this direction, westerly winds. In that also, intensity like 2 to 3 knots, 4 to 6 knots, which speed or which wind intensity is more, you can see over here which type of speeds. Like wind speed of 2 to 4 knots will be of this much range only, wind speed of 4 to 6 knots will be of this much range only, wind speed of 6 to 10 knots will be this much range only. That is the meaning of it. Fine. So any doubts in this, you can ask me. Windrows diagram. Please repeat crosswind component. Kushbu Ja. Please repeat crosswind component. Crosswind component, like see, if winds are moving like this, it's fine, but throughout the year winds will not be moving like this. Winds can be moving like this. Winds can flow like this. When winds are flowing like this, it will be having two components. One component is V cos theta, other component is V sin theta. That is in the transverse direction. So when aircraft is moving like this, when aircraft is taking off like this, if there is crosswind component, initially it might be going like this. Because of crosswind component, it can go like this, because the wind helps in moving the aircraft. Whereas while landing, that means when it is landing like this, if there is crosswind components, it will not allow it to land. It tries to push it off to the top. So there will be turbulence created. You are trying to land off, but wind is not allowing. Then you will go up, then you land, then you will go up, then you land. So this is the turbulence generally that is created while landing. So if your pilot does not land properly, means he is not able to understand the wind components properly. That means he is not an efficient pilot. So the efficiency of pilot depends in takeoff and landing, that is crosswind component. Okay, so any doubts in crosswind component and then this windrose diagram and all those things, any doubts? Any doubts, please do comment guys. Please do comment. Any doubts, please comment if you are having any doubts. Clear? Fine. So this is windrose diagram and that is the different things. Next one is basic runway length. Basic runway length. Basic runway length. Basic runway length. It is the length of the runway. It is the length of the runway. It is the length of the runway. It is the length of the runway under assumed, under following assumed conditions, under following assumed conditions, under following assumed conditions, that means that is the length of the runway. Generally if you see runway, there will be two types of things, there will be runway and there will be clear way. This is runway, this is clear way, this is generally this will be a width of 500 meters. So whenever I am talking about runway, basic runway length, this is the basic runway length. There will be two types, while if it is normal takeoff or whether there is emergency landing. So maximum of, if you ask me runway length is generally given as maximum of during normal takeoff and during emergency landing. Considering both the cases, you will give basic runway length. Fine. So there are many calculations, that is not important over here. So runway length will be maximum of these two things. So under following assumed conditions, what are the assumed conditions? If you see the assumed conditions, airport is at sea level. Airport is at sea level. Airport is at sea level. That is first thing. That means we assume that first airport is at mean sea level. Then we will do correction for some amount of elevations. Mean sea level is generally taken at Mumbai. Mumbai mean sea level. We assume first airport is at mean sea level. Then we will do correction for elevation. Next one is airport is at mean sea level. Next one is airport is at airport or temperature at airport is standard temperature. Temperature at airport is standard temperature. Standard temperature at 15 degrees Celsius. Standard temperature at 15 degrees Celsius. Next one is temperature at airport is standard temperature 50 degrees Celsius and airport is leveled. Airport is leveled in longitudinal direction. Airport is leveled in longitudinal direction. So airport is leveled in longitudinal direction. That is C. Option C is airport is leveled in longitudinal direction. This is your, that means there is no gradient. There is no gradient. That means you have to do the correction for gradient also. Next one is no winds in prevailing direction. No winds in the direction, the given direction. That means if winds are there, it helps takeoff of landing, but we are assuming there is no winds and we are designing it. So that if winds are there, so we will be on safer side. Okay. So no winds in given direction, or in direction to the destination there is no winds. So these are the major assumptions. Under these assumptions, whatever the runway length you give, that is called as a basic runway length. So basic runway length is the runway length under the following assumed conditions. So these are the major conditions. We will be considering these conditions, and he will give you some basic runway length. Now you have to do corrections for this basic runway length. So corrections, if I have to see corrections for basic runway length. Corrections for basic runway length BRL. Corrections for basic runway length BRL. Corrections for basic runway length BRL. So the different points that you have to see in corrections for basic runway length is, first one is correction due to temperature, correction due to elevation, correction due to altitude, correction due to altitude or elevation, correction due to altitude or elevation. Fine. So correction due to altitude or elevation, if I talk, if you increase the elevation, if you are going at the higher heights, then what happens? Air density decreases. If air density decreases, that means air becomes lighter, then uplift pressure on the aircraft reduces, right? Uplift, this wind components will be uplifting the aircraft, right? So uplifting on the aircraft will reduce. If uplifting on the aircraft is reduced, then what you have to do is you have to provide longer runway lengths. So that, see, generally if you want to run faster, like if you want to jump, what you will do in high jumps also, you will run and then you will jump, so that you will get proper elevation, right? Same thing. So if, let us say, if there is wind, if you are running this much amount of length, if there is no wind, you have to run more amount of length, so that you get the same amount of speed. That means length of runways is increased. Fine. So the points would be, at higher elevation air density decreases. At higher elevation air density decreases. This is first thing. At higher elevation air density decreases. So the uplift pressure on the aircraft, also reduces, resulting in requirement of longer lengths of runway, resulting in requirement of longer lengths of runway. So from here what you can say, generally runway length of runway is increased by 7% for every for every 300 meters, rise, for every 300 meters of elevation from MSL, that is mean sea level. For every 300 meters of, there will be 7% rise, or length of runway should be increased by 7% for every 300 meters of elevation from MSL, from mean sea level. For every 300 meters of elevation, it should be increased by, the length of runway should be increased by 7%. Any doubts in this? You can ask me. Good morning, Prashant Kakarla. Good morning. Any doubts in this? Correction due to elevation? Any doubts? Why there is gap? Any doubts? How to define basic runway length? Basic runway length I have already given over there. Basic runway length is the runway length under assumed conditions, and it will be the maximum of the runway length that is found out during normal takeoff and emergency landing. So, sir, how exactly you will calculate runway length? That is, you will be getting it from your mechanical engineering guys. They will be giving you what exactly is basic runway length. Based upon that, speeds and all those things they will calculate, and they will give you the runway length during normal takeoff and during emergency landing. Based on that, you will find out a runway length. That is, length of the runway is called as runway length. What is there in that? Any doubts, guys? Any doubts, guys? Any doubts? Any doubts? If length is restricted, then how to increase the length? Example, Mangalore Airport. If length is restricted, like in terms of Mangalore Airport, then we have to change the designs. Change the designs of the aircrafts. If length is restricted, then we just have to change the designs. Like speed will be restricted on the on air, flight speed will be restricted. So while landing, they will say that your speed has to be decreased. So based on that, the pilot starts reducing his speed from the far distance, so that just before reaching the airport, his speed will be reduced, so that the length runway length will be provided less. If he can't reduce his speed, then what he does is he'll keep on rounding over there only, slowly he'll keep on rounding, slowly he'll come to that point, and then he will reduce. That is the thing, that is the only thing. If length can't be if length is restricted, then you have to reduce your speed. And what is the another doubt Bhaskar sir has asked? What is bubble top airport? Bubble top airport, I think, are you talking about this bio bubble recently that we guys are traveling, from India to China? Is that what you are talking, bubble top airport? Please be clear with that. because that is the advanced version of it. It's just like providing bubble top and okay, restricted runway due to space restrictions. Yeah, okay, that is different, because recently we are talking about this bubble top airports or bio bubbles. It's like, you know, whether they are able to provide proper care about the people. But no, if you are asking about this restricted runway due to space restriction, then we have to reduce the speed. We don't have any other ways. The pilot has to reduce the speed and make sure that he gets this much amount of runway only. It's all like playing with the prevailing wind conditions and the speed of the aircraft. Fine. So this is correction due to runway, correction due to altitude and runway. Next correction is correction due to temperature. Correction due to temperature. Correction due to temperature. What happens if temperature rises above the standard temperature? What happens? If temperature rises above the standard temperature, what happens? Obviously, air density decreases. If temperature increases, density of air decreases. If density of air decreases, uplift pressure decreases. If uplift force decreases, automatically it requires longer lengths. Same thing. If temperature increases, air becomes lighter. If it becomes lighter, then uplift force decreases. Right? The same thing. Correction due to temperature. It has same effect as that of same effect as that of elevation. It has same effect as that of elevation. That means because of the increase in temperature, air density increases. If air density increases, the takeoff uplift pressure decreases. If uplift pressure decreases, then it becomes difficult. It requires longer runway lengths. Fine. Generally there is a thing called airport reference temperature, ART. Airport reference temperature. Airport reference temperature, ART. So airport reference temperature, ART, is generally given as TA plus Tm minus TA upon 3, where TA is mean of monthly mean of average daily temperatures of hottest month, average daily temperatures of hottest month. TM is monthly mean of maximum daily temperatures of hottest month. In a given day, there will be average temperature, at the same time maximum temperature. In the afternoons, there will be maximum temperature. Average temperature is from morning to evening. On an average, what is the temperature? So average mean of average daily temperature of hottest month is TA. Mean of maximum daily temperature of hottest month is TM. Based on that, you will calculate airport reference temperature. Next, standard temperature. Standard temperature is generally given as 15.5 degrees Celsius minus 0.0065 multiplied with elevation above MSL. From this is how you will calculate standard reference temperature. And correction is or increase in runway length, increase in runway length is 1% for every 1 degree Celsius, 1% for every 1 degree Celsius rise in temperature, 1% for every 1 degree Celsius, 1% for every 1 degree Celsius of ART above ST. ART is airport reference temperature above standard reference temperature. That means you will calculate ART, you will calculate standard reference temperature, the difference you will calculate for whatever the difference. For every 1 degree Celsius there will be 1% increase in the runway length. So, if there is 10 degree Celsius difference, then the increase in runway length would be 10%. Fine. So, next the note would be, you can write a note, the increase in the runway length, the combined increase in the runway length, should not be more than combined increase in runway length due to elevation and temperature, should not be more than 35%, should not be more than 35%. If it is more than 35%, then you have to redesign the runway. Fine. If it is more than 35%, redesign the runway. So, if it is more than 35%, you have to redesign the runway. That means, like as I said, if space is restricted, then we will reduce the speed of the aircraft. Same thing, we will redesign the runway. Fine. So, this is the things that you have to remember. This is correction due to temperature. Any doubts in this? You can ask me. Hello, Deep Patel 2403. Any doubts, guys? Please do comment. In redesigning, same experiments means what? Which experiment I am talking about? Yeah, same thing, Narendra. In redesigning, you will send it back to the mechanical guys saying that the runway length is, after correction due to temperature and all those things, the runway length is more. So, please redesign the runway and all those things we will do. No doubts? Fine. So, next one is correction for gradient. Correction for gradient. correction for gradient. Generally we try to avoid correction for gradient, but anyway if there is steeper gradient, if the gradient is there, then it's like 20% for every 1% increase in the gradient. You can say 20% for every 1% increase in gradient. For 1% increase in the gradient, then you will be 20%. I mean, you will increase the correction for 20%. Fine. That means if gradient is 1%, 1 in 100, if gradient is 1%, your runway is something like this, that is 1 in 100, then you will increase the runway length by 20%. Fine. So, any doubts in this? You can ask me. Any doubts? Not 20%, 20 meters, sorry, not 20%, 20 meters for every 1% increase in the gradient. Yeah. 20 meters for every 1% increase in the gradient. See, that is, if combined correction is less than 35%, then only you go for correction for the gradient. If combined correction is more than 35%, you will restrict your length to that one only. You will not do correction for gradient then. Combined correction should be less than, combined correction due to elevation and temperature should be always less than 35%, then only you will go for correction for the gradient. If it is more than or equal to 35%, you will restrict your length to this. You will not go beyond this. Fine. So, any doubts up to here, you can ask me. Any doubts? If you are not having any doubts, please solve it. Length of runway under standard conditions, length of runway under standard conditions is 1620 meters. 1620 meters. The airport site has an elevation of 270 meters. If airport reference temperature is 32.9 degrees Celsius, directly given to you airport reference temperature, and runway is to be constructed, with effective gradient of 0.2%, then determine the corrected runway length. Then determine the corrected runway length. Please find out. Obviously, sir, there are many norms for airports. What should be the thickness, what should be the lens rest. I am just discussing about the lens. There are certain geometric designs also, exactly like we see in the highways. What is the super elevation that is restricted, what is the velocity design speed, and what should be the curves when you are using the curves, what should be the radius of the curves. All those things is, there are certain norms for that, but from exam point of view that is not that much into the criteria. So I am not discussing much. Why? Because hardly you will get 2 marks whether it is GATE or engineering services. So that 2 marks from the previous year's experiences where we generally get. So I am discussing that areas only, but whatever the norms that is present, this is also like roads only. So there also you will find super elevation, here also if there is curves. In taxiway indirectly there will be curves, here also you will find the super elevation and lateral friction, all those things, but it will be less. The norms, if you want to go into deeper depth, then you have to see that Airport Authority of India manual, and from exam point of view it is not advisable because it takes huge amount of time. So very basic idea is being discussed over here. Please solve the question, guys. Good morning, Akash Sukla. After a long gap I am seeing you. Good morning Akash Shukla. One person has given Narendra 2072.31 meters as the answer. What about the other guys? What about the other guys? 12 people are watching. What about the other guys? What is the answer? Only one person has given. So standard conditions, first basic runway length is given to you, BRL. Basic runway length is given as 1620 meters. First is correction due to elevation. Correction due to elevation. So when you are doing correction due to elevation, I will write it as LE. After length after correction due to elevation would be 7% for every 300 meters. What is the elevation here? 270 meters. So 7% for 300 meters. For 270 it is 7 into 270 upon 300 multiplied with 1620 plus 1620. What is this value? What is this? 7% for every 300 meters, right? Height. So what is this value? 1620. Good morning, Neeraj Kumar. Seven multiplied with 270 divided by 300 multiplied with 1620 divided by 100. So 102.1 plus 1620. So this would be 1722.06 meters. This is correction due to elevation. I mean length of runway after correction due to elevation. Next, airport reference temperature, that is given as 32.9 degrees Celsius. Standard temperature, that is 15.5 minus 0.0065. Elevation in meters, that is 270. What is this value? 0.0065 multiplied with 270 minus 15.5, that is 0.0065. 13.745 degrees Celsius. So difference in temperature, difference in temperature would be 32.9 degrees Celsius minus 13.745 degrees Celsius, that is 19.155 degrees Celsius. Fine, this is difference in temperature. Then length of runway after correction due to temperature, temperature equals to, I will write it as LT, that, so for 1% for every 1 degrees rise, what would be the rise here? 19.115 degrees. So it would be 19.555 percentage, that is divided by 100 multiplied with, what is this value? 1722.06, 1722.06 plus 1722.06. So correction after applying correction due to temperature, (1.1955) multiplied with 1722.06. 1722.06. So this would be equals to 2058.7 meters. 1.19155 multiplied with 1722.06. So this will be approximately 2052 meters. 2052 meters, right? So this is 2052 meters, that is correction after temperature and elevation correction. You have to check the note over here. What would be the note? 2052 minus 1620 upon 100. 2650 minus 1620 upon 1620 into 100. So that should be is 2052 minus 1620 divided by 1620 multiplied with 100. This is 26.67%, not greater than 35%, therefore it is okay, safe, fine. Finally, correction due to gradient. Correction due to gradient. It is given as 20 meters for 1% rise. 20 meters for 1% rise. So final length would be equals to LG. I'll write final length, or I'll write final length of runway. Final length of a runway. Final length of runway equals to 20. For 1% rise, it is 20 meters. What is given? That is 0.2% rise, right? 20 multiplied with 0.2 upon 100 multiplied with 2620 plus 2062 or 2052 or 2052. 2052 plus 2052. So this value is 2.2 multiplied with 20 that is 2134.08 meters, approximately 2135 meters. This is how the length of runway is designed. Any doubts? No, you have to give temperature correction after elevation correction only. Why? Because standard temperature is calculated based on elevation. That's why. Any doubts, guys? Any doubts, guys? Any doubts? Fine. Sometimes in the examination, if they are saying temperature at mean sea level is 15 degrees Celsius. If temperature at MSL equals to 15 degrees Celsius, if temperature at MSL equals to 15 degrees Celsius, then standard temperature would be calculated as 15 minus 0.0065 multiplied with elevation from MSL. Okay, standard temperature multiplied with minus 0.0065 elevation from MSL. Okay, so if not 15 degrees, whatever they say, then you will be using that only. In that case, in this case, what you will be doing is, first you will do correction due to elevation, correction due to elevation equals to 7% for every 300 meters. Next, correction due to temperature. If you are calculating correction due to temperature, then ART, airport reference temperature, would be TA plus Tm minus Ta upon 3, and standard temperature, standard reference temperature, standard temperature 15 minus 0.0065 multiplied with elevation, elevation above MSL, elevation above MSL, and 1% for every 1 degree Celsius of ART above ST. Fine. This is correction due to temperature, and finally correction due to gradient. Correction due to gradient. Correction due to gradient. 1% for every 1% for every, not 1%, 20 meters for every 1% rise. 20 meters for every 1% rise. 20 meters for every 1% rise. So these are the different criteria that you should remember. Generally, if nothing is mentioned in the question, also use this one only. Instead of 15.5, maximum recently the questions they are asking from 15 point of view only. So you can use this one only. Nothing is mentioned. If nothing is mentioned in the question, or unless and until if they say mean sea level temperature at mean sea level is 15.5, use 15.5. If nothing is mentioned in the question, use 15. Use 15. Okay. Use 15, don't use 15.5. That is standard version. Initial they have developed that, and after that in the recent problems we are using this. Fine. Any doubts in this? You can ask me. Any doubts, guys? Any doubts? No doubts? Fine. So this is runway design. This is the runway design. Next one is taxiway. Next one is taxiway. The name itself says it is taxiway. It is the place where this aircraft will be moving from one runway to the another runway. So the roads that connects from one runway to the another runway, or if this is a runway, this is another runway. The roads that connects from one runway to the another runway. Fine, this is one runway, this is taxiway, this is another runway. The road that connects from one runway to the another runway. At the same time, the road that connects from runway to the apron or apron hangars. That means, if let us say there is a road, your flight comes, your flight goes, and it will be staying over here, let us say. Fine. So here there will be a taxiway. Your flight comes, your flight goes, this is the apron or hangars. That means your flight goes and it stays over there, flight will be hanging over there, so that it will be loaded. This road is called as taxiway. This is runway, runway, this is called taxiway. So taxiway is the road that is provided to connect runway to the aprons or hangars where it is loaded, or it is used for connecting one runway with the another runway for smooth flow of the flights. Fine. So if there is a landing of flight in one runway and there will be taking of flight in the another runway, so that these two things will not clash. Fine. So all those things will be managed by taxiways, or indirectly all the other roads except runways, that is considered as taxiways. All the other roads except runways, that is considered as taxiways. Fine. Any doubts? Any doubts? Thanks Raunit for your kind words. Any doubts? This is called taxiways. So taxiways are the roads which connects runways runway with aprons or hangars where flight is loaded or unloaded, This is taxiway. Fine. Next, it connects, taxiway connects different runways in the airport, Sufficient length of taxiway should be provided. Sufficient length of taxiway is provided. Sufficient length of taxiway is provided so that takeoff in one runway is not affected by landing in another runway. Fine. And runways can be, taxiways can be straight, it can be a straight roads, or it can also be at horizontal curves also. Fine. Anyway, any doubts in this? You can ask me. Hey Prachi, good morning. I think you just woke up now. And what happened to Narendra? I think he left. You got bored? You left? Any doubts in this, guys? Any doubts? You have doubts? What is the doubt, Prachi? आपका डाउट क्या है? Fine, and you can take a point. I have given in runways. I have given airports, type of airports based on runway lengths. Type of airports based on runway lengths, if you remember, I have given it from A to E. So this is longest runway length. You can take a note over here. longest runway length, and here you will be providing shortest runway length, Here minimum, if you see the minimum here it would be 2100 meters, minimum here it would be 160 meters, sorry not 160, 600 meters. Minimum runway length would be 600 meters. This is the shortest runway length, this is the longest runway length. In that the minimum criteria is this 2100 meters and 600 meters. Points can be asked, and gradients also. Here it would be 1.5%, here it would be 2%. This can be variable, but I am saying the minimum criteria. This is the note. You can take this in runway lengths. Anyway, we are discussing taxiway now. So in taxiway, this is the meaning of the taxiway. There are different, whatever the roads that we have constructed in the highways, same thing is applicable over here. The only difference is if there is any horizontal curves, in taxiways, then radius of curve, there will be two criteria that will be given to us. Radius of curve is given from two criteria, r equals to v square upon 125 f. The very first criteria is r equals to v square upon 125 f, where v is the speed of aircraft in kilometers per hour. F equals to lateral friction. Generally, if nothing is taken, it is taken as 0.13, whereas over there we are taking 0.15, and there is no question of super elevation here. Fine. And for subsonic jets, minimum R is equals to 120 meters. For supersonic jets, minimum R equals to 180 meters. Subsonic, supersonic, based on the speed it is divided. So for subsonic jets, minimum radius is 120 meters. For supersonic jet, minimum radius is 180 meters. Fine. So this is first criteria. Next criteria is empirical formulas. As per empirical formula, radius equals to 0.388 W square upon T by 2 minus S. Where W is the width of the wheelbase. S equals to 6 meters, 6 plus tread of gear upon 2, and then T equals to length of landing gear. So maximum of these two criteria you generally provide. This is an empirical formula. Okay, this is just an empirical formula. Any doubts? No doubts. Sometimes this can also be given as width of taxiway pavement, or just take it in a width of taxiway pavement, width of taxiway pavement in meters, width of taxiway pavement in meters. What exactly is S? If you want me to show in the figure, if this is a flight or aircraft, there will be wheels, right? There will be wheels. Distance from here to here is called as S, and this is T, and this whole thing is W. That's it. Width of wheelbase of aircraft in meters, width of the taxiway in meters, and S. S is the distance from the mid of the gear to the end of the taxiway, mid of the gear to the end of the taxiway. So this is the thing that you have to remember. Fine. So based on these two criteria, maximum of these two criteria will be given as the radius of the taxiway. This is generally taken as 6 meters. 6 meters, it is tread of gear. Tread of gear. So 6 tread of gear, GEAR. This tread of gear by 2 plus this is 6. 6 plus tread of gear by 2 is S. This is aircraft, and I am showing the wheels of the aircraft. S is not T by 2 here. S is not T by 2. Who told you S is T by 2? Have I said S is T by 2? This is S, not T by 2. There will be difference will be there. This is minimum of 6 meters. Tread of gear would be different. It is not T by 2. T by 2 minus S. That distance is what, the difference is what we are more worried about. Fine. Try to solve a question. Try to solve a question. A taxiway is to be designed. A taxiway is to be designed for operating aircraft, having following characteristics, having following character, wheelbase equals to 17.70 meters, tread of main landing gear, tread of main landing gear equals to 6.62 meters. Turning speed V equals to 40 kilometers per hour. Coefficient of friction between the pavement 0.13. Coefficient of friction between the pavement 0.13. Generally, thickness of T would be equals to 22.5 meters. If nothing is mentioned in the question, you can take it. T is width of taxiway pavement, that is generally taken as 22.5 meters. Please give me the answer. What is the answer, guys? Give me the final answer. Who asked you through empirical or other things? I think I'll ask them today, Chirag. Today I'll ask them and I'll see whether they'll able to do that playlist or not. What is the answer? How much time you'll take? So, you see, if nothing is mentioned in the question also, you can take the width of the taxiway pavement as 22.5 meters only. Fine. See, I am showing it on the taxiway here, but actually how it would be, there will be a straight road that will be converting like this curve. Whenever I am showing curve, it will be converting into a straight road, will be converting like a curve, or let us say there will be straight road like this. There will be another straight road like this. There will be another straight road like this. So road will be, one road will be moving like, straight road, curve and a straight road. When it is rotating like this, when the flight is rotating like this, then you will see that S would be different from T. Okay, S you will calculate when once if it is in the straight road, then you will calculate S, and once if you go here, then it would be different. Fine. So taxiway is not equals to T by 2 is not equals to S. In the figure you might be seeing like that, but initially this 6 meters or whatever it is, this is the minimum value. I am taking this as 6 meters, 6 plus tread of gear by 2, but this value can also change. It may be given in the question, right? So S is generally defined as S equals to distance from mid of tread gear, mid of gear or tread gear, whatever you want to say, that is called as tread gear, mid of tread gear or gear to the edge of taxiway pavement, to the edge of taxiway pavement. So both the things will be generally different. Fine. So that is generally 6 plus tread of gear upon 2. Okay. So both the things will be generally different. So don't take the T by 2 equals to S. There will be small amount of difference will be there. Fine. So if coming to this problem, the first criteria, from the first criteria, R equals to V square upon 125 F, that is 40 square upon 125, F is 0.13. How much you are getting? Please give me the answer. Second criteria, 0.388 W square upon T by 2 minus S. 0.388 W is 17.7 square, T is 22.5 by 2 minus S. S is 6 plus what is the tread of the main landing gear? 6.62 by 2. 6 plus 6.62 by 2. So what is this difference? Radius. What is the radius from here? Please give me the answer. 98.46 meters from here. 98.46 meters. And what is from here that you will be getting? 62.65 meters. 62.65 meters. And he has not mentioned any subsonic or supersonic jet. He said normal aircraft. If it is subsonic jet, then it is minimum radius is 120 meters. If it is supersonic, minimum radius is 180 meters. So final turning radius, this is also called as turning radius. Turning radius R equals to maximum of 98.46 and 62.65 meters. So turning radius equals to 98.46 meters. If he has mentioned subsonic or supersonic jet, then you will provide 120 or 180. Maximum of those three things you will consider. Fine. So this is how you'll be solving these type of questions. Find turning radius for taxiway. There are other things also, fillets, mid fillets and all those things, but very rarely we'll see those type of questions. And yeah, whatever that I have given, it's from exam point of view only. Don't think that this is the only thing that is there in the airport. Fine, there are many other things, but majorly questions from here is asked, so that's why I have discussed this. Okay, so with this I am closing airport. In the airport, what we have seen wind direction, wind rose diagrams, runway design and taxiway design. Not much, because if I start doing it, it will be, I mean, from exam point of view only I have taught. Major points were discussed. Some points here and there might have been left, and it's not like whatever it's a vast syllabus. Total transportation engineering is a vast syllabus. So whatever I have taught, it's only from exam point of view, that is very basics. From this you can easily score 90% of marks. Like I already told you, like if you score 65 to 70% of marks, then you will get your first rank. So keeping that in that perspective, I have discussed all those things. If you find any new things, any new concepts, then you can ask me. You already have my number. I'll discuss that with you. At the same time, try to, if you find any new question, new problem over there, try to understand that. It's like numericals, all numericals you will be able to solve, maximum number of numericals. Theoretical questions, 1 or 2 theoretical questions will be there, that suddenly he might give it from somewhere, like sudden place he can give, that you can't expect. If you don't know, leave that question. If you know, try to attempt it. So that's what I'll say. So final notes of transportation engineering, this will be your end of the transportation, and my number is 9873414725. so please take my number, and whatever the doubts you are having, you can ask me over there, either WhatsApp or Telegram or message. Calls are also okay, but sometimes I don't pick up the calls, and sometimes I delay the doubts because of the other work. So please don't mind, I'll solve your doubts by now or then. Okay, so I took structural analysis and transportation for you. I don't know if in future another subject will be given to me or not. At the same time, your examination is on July 18th. So please be very cautious and try to solve, exactly 1 month before the examination. I think I am closing my subject. Of course, it is difficult for you to revise and all those things also. The best thing to do is try to solve previous year's questions as soon as possible and as many times as possible. That is the best thing I can say. In 1 month, what you can do, try to solve previous year's questions and give much time to the non-technical things. So it's like your idea is to score 100 from the non-technical, 150 from the technical. So if you are reducing like 80 in non-technical, score 170. Your target should be like 170 fix. It's not like it should not go down. And if you are scoring only 60 marks in non-technical, then you should score 190 to 200 in the technical. So for everything, if you ask me for technical, please solve previous year's questions. You can easily score up to 200 marks. Some 100 marks, like new theoretical concepts will be there, or problems which will be taking much amount of time will be there. But the other things, no point, other things you can easily solve from previous year's questions only. So that is the best idea I can give, and please be patient, confident, and don't get tensed before the examination. Do whatever you can do. Fight till the last minute. After that, just come out of it. You'll be having an idea. We'll be releasing the key. Based on the key, you'll be having an idea what is what, and after that, it's not in your hands. If you have done well, so just wait for mains. If you have not done well, then go for another examination. There is GATE, state services, and all the other examinations. And yeah, it's been great journey with you. If you ask me, Prachi and Narendra, these two guys were constantly there from the starting of, I think I started in April, I think, and I got some corona and I have delayed in May, and June, after a long gap, I am completing it. So sorry for the delay, guys, and it's been a great journey with you, and at the end I have seen Kushbu, Bhaskar and the other guys joining here and there. Akash Shukla was also there from the starting. So yeah, it's been a great journey with you, and all the best for your future. If you have any doubts, please contact. And this is Karthik Mandalapu, finally signing off. Have a great future. All the best for your exam, guys. Bye bye. If you're having any doubts, you want to say anything, please go ahead and ask. Next time come with RCC. I don't know whether I'll come for next time or not. कि engineering economic की questions आएगा, ये question भी बिना calculator की नहीं हुआ. See, engineering economics की that type of questions you have to solve it here. You have to solve it from practice. You will get it. It takes time. That is what I said. Those type of questions will take 5 minutes of time. So you have to leave other questions to solve these questions. You can't do anything. बिना calculator से you have to practice and you have to do it. We can't do anything. Thanks, thanks Bhaskar sir, thanks Kushbu, thanks Prachi. Approximation से भी हो जाएगा. Kushbu, please explain why tread gear is 6.62 meters. This distance is 6.62 meters. Maximum this distance would be 6.62 meters. If you go and you check, that would be 6.62 meters only. What is their doubt? Kushbu. Fine. So it's great journey with you. Bye guys. As I said, all the best for your future. Any doubts, anytime you can always contact me. And yeah, I don't know, I think for this month I don't think so I'll be taking any videos. I have some recording works. So next month if possible we'll meet. Bye bye. Bye. Tata. All the best for your future.